Hi all, this is Leslie, and today's topic is how to live coding of Retracing Your Weekend series, and we are starting the second book, Retracing the Next Week. So this series is on hiatus for a while. The last time I said I would do a refactoring episode, but later when I look at the code base, I kind of find out the main unsatisfactory of me on this code base is on the usage of random module, because we just have a lot of those kind of random floating around, and that is not something easy to fix, because that random is basically from the base library, which we kind of use it as the standard library. And because it's global mutable, it will be kind of, it is everywhere and hard to test, hard to understand. And more importantly, when we start to do some kind of multi-threading, this thing will be our performance bottleneck. But I will leave it here now until we really need it, which is when we finish all the 3 books and when we start to do something extras, for example, multi-threading, and then I will try to spend an episode to refactor random. Just not use the base library facility, instead write our own, basically, which is unfortunate. Today our topic is this book, Retracing the Next Week. I think we will only finish the second chapter, Motion Blur, because bounding value hierarchy is really complex, so I will put another episode, a whole episode on it. So let's start with Motion Blur. When you decided to retrace, you decide that visual quality was worth more than runtime. That's no longer true. So there are a lot of cases where we use ray tracing for real-time rendering now, and we need to care about the runtime performance. But it is definitely not in our code. Our code's runtime is very slow, and I don't even care. So and last time, this is a result of last time we implemented 3 materials, and we can do a lot of objects, retrace a lot of objects like this. If this image is too small, because I rendered this on the stream, I also had a high resolution image rendered afterward. But this one takes like an hour, so the idea of motion blur is where I still haven't installed. Why? Oh, I do. Is our sphere can move. So like at t equal to 0, it is here. At t equal to 1, it is here. So at t, if we put an array at t equals to 0, and it will intersect with this sphere. But if it's t equal to 1, then because sphere is already here, we will no longer intersect with this sphere. And that will give us some nice result if we have a lot of arrays and send them at random time step. It's kind of mimic the idea of a camera have a exposure of not a just time point, but a range of time. So the book starts from add a time number into each ray. So our ray will have a timestamp. It doesn't matter for the add the time parameter. So we just stop it out, and then I will expect some kind of build failure because of the signature change. Added is a ray crate, so I need to put time. Added. No, this is not the right time. So, sorry about that. When we scatter the array, we just put the original array's time. What? No. Not 0. Because we're not considering light speed, for example. We just treat light ray as infinitely fast. It's good enough approximation. Test. What? Oh. But in test we can just put 0 because we don't even care about the time of those rays when our sphere are not moving. What? Oh, it's in main. I want to open it here. Put back. Because we haven't changed camera yet. That's understandable. So I think the next part of the book is changing the camera, where we kind of have an exposure time from start to the end. And when we generate array, we just pick a random floating point number between the start and end as our timestamp. Great. We need two optional, defaulted. This is a syntax like this. I'm always confused about this syntax. Yeah. What is this? Oh, I see. Because we don't have any positional parameter, the compiler gets really confused. So if we want to have this kind of defaulted parameter, but we don't want to use them, we need to add at least one positional parameter like this. We just put a unit here and don't use it. The ugly part of the language. Okay, I think we're good. That should fix the type error here. And for the test, no, it's line 86. It's a problem. Well, first, here is a problem, and I think this R have a problem. Yeah. Oh, we're good now. Everything compiles. Nothing. We haven't changed anything. Let's just do some sanity check. Even though our test coverage is pretty low at this point, because of the random. Every test pass. So the next step of this book is to add a moving sphere that have center 0, center 1, and it just move kind of in a constant velocity between those 2 points and 2 time step. And it is basically a copy of the sphere and just changing a few bits. So one thing we need to talk about for our current implementation is our scene is not polymorphic at all. It is currently hard-coded into a list of sphere. But if we add moving sphere, the thing gets more complicated. And I think we will spend the majority of this episode to solve this problem. But for now, let's first implement moving sphere. What am I doing? Since the majority of the parts of moving sphere is just copied from sphere, we will just copy that file. Can do some refactoring later to remove the duplication of code. If we have time, otherwise I will do it next time. And now this is moving sphere. By the way, I still don't know what is the best practice of exposing modules. I use this way, but to be honest, I don't know. There are probably better ways to do it. So for moving sphere, we can also have tests. I will even say that every test on sphere should be tested on moving sphere. And this file already gets a bit cumbersome, so we need to put it into separate files later. And wait. Sphere, resphere. that everything is still okay. Later we need to change how to construct moving sphere, and do we even use moving sphere too? So for our moving sphere, we will have center at time 0 and center at time 1, and of course we will have two timestamp to indicate the time at center 0, center 1. What am I doing? We need a function. We need a function to calculate the current center of the sphere, which is a linear interpolation of the time at center 0 and center 1 of the 2 points, center 0 and center 1. I think we have a linear interpolation function already implemented, so let's just use that. And the time is this thing. Not the time, but No. I'm writing OCaml for a while, so it's standard. I think basically we just change the way of calculating center to using our time. Yes, or center. This is not nice. Yep. And now we need to change our move sphere construction to match what the grid function here. What am I doing? Let's make it from -1 to 1, moving from -1 to 1, and as the axis and time is 0 to 1. Now everything passes, but we haven't tested anything for the functionality of the moving yet. So let's quickly add something. So this exactly same test if the ray is shooting at time 1, then because our sphere is already moved away, we will not have any intersection. Okay, it passed. I think that's enough to demonstrate the point, even though this probably not covered every potential cases. This we already make the change, and without this change, as we have seen before in the material, we can not even compile our code. So thank for the type system, we don't need to do anything. Now it's the tricky part, and we will spend the next whole string on it. It's how to make the thing polymorphic. So currently our thing is just sphere. And as we can see, sphere and moving sphere are two completely unrelated modules, and because of that, we currently have no way to just use those two modules in the scene together. Of course, we can let a thing store a variant of sphere and moving sphere, but when later we add more primitives, this approach kind of becomes cumbersome. And every time we add a new primitive, we need to modify the thing because it is a variant basically. So variant is a good approach for polymorphism, runtime polymorphism, as long as, but it's not open to extension. In a retracer like this, we want to add a bunch of different primitives, so we want open to extension. So variant is not a choice. What we would do is something called first class modules. In a lot of functional languages or even non-functional languages, we talk about first class as first class citizen of the language, and mainly it's first class function because not in all languages function a first class citizen. When we mean first class, we just basically means we can treat this thing as a value, like we can store it, bind it to a variable, we can pass it into a function, and we can return it from a function, this kind of thing. And in OCaml, there is something called first class module. So that's probably a surprise for a lot of people, because even in languages with heavily ML heritage, like for example Haskell, Elm, Scala, Rust, whatever, they don't have this. And only standard ML, OCaml, which is kind of direct children of the original ML, have this feature. So let's just be clear, module in OCaml itself are not first class. Otherwise, there will be some kind of performance hit we don't want. However, just like, for example, a function in C is not first class, but C have function pointer, which is first class, and it's similar. A module in OCaml is not first class, but there is first class module as a separate language construct that allows us to store module into a structure, for example. And the first thing we need to do is create some kind of module interface. Let's call it shape. The shape have a type. What? So I think I forgot the syntax of how to define such kind of things. So have a quick search. OCaml module interface file. Probably we cannot use this shorthand. Yeah, that looks reasonable. So all of our shape need this heat function to calculate the heat, to calculate the intersection, and we need some kind of grade function, but that don't need to be exposed in here because grade is not polymorphic. When we create a moving sphere, for example, we need to know it is a moving sphere. If you look at this C++ code base where we have this inheritance, it is really similar to the idea we used here. Just in OCaml, if we want this kind of open to extension, the polymorphism, the way to do it is through first class modules. And now in the scene, T can no longer be a sphere, but it needs to be a sphere instance. Well, the instance of the what is it called? The shape. So we need another module. Module signature. I will just make it. Is the syntax like this? I'm always confused about this syntax. That's some main reason behind the reason ML is the syntax of OCaml is just like very easy to forget, at least for people not doing OCamls all the time. And in here we need some kind of higher order module how to do we do this? We also need functor. Sorry, I need to look at how to do this again. I remember in the book Real World OCaml, there's a chapter talking about how to do this kind of stuff. Just cannot remember the syntax. think this one is because we haven't built yet. That is true, we don't want to implement shape. Apparently we need to tell our build system about this. Not here. Why shape is unbounded? Does that mean I cannot do that? I must put shape also in here. Okay, let's do this. I just feel like shape does not belong to scene, and I don't want to put it in the scene file. And if they don't tell me, I definitely forget how to do this locally abstract type. So thanks this book, I will just copy and paste this code and look at how to do this. Not sure if something like this will work. Oh, I think we need to pass in. Instead of using create function inside build shape, because we don't even know what our create function looks like. If you're more familiar with OO language, then you know kind of constructor are special. You can construct are not polymorphic, because when you construct an object, you need to know what that is, and you probably even need to pass different parameters than some other objects, even though they are polymorphic to each other. And we will do the same thing here. So we pass a not polymorphic shape in, and it should have type S. Or just type A. And then construct shape instance, which is polymorphic because we used first class module in here. Now I think time to change this to shape instance. Which is a module, so not a module but a first class module. To use first class module, we need to unpack it back into the original thing. So it here is I forgot how to pass higher module in, or first class module in as is it just like this? I think that's good. How to unpack it? Sorry about I need to look at the syntax of how to do this every time, because I just don't do this kind of thing too often in OCaml anyway. And generally, I don't write polymorphic code like this too often in C++ also, or in other languages. Yeah, we still need let binding. And this is a list, not. So it's not even here, but inside the function, which is the lambda that pass when single individual shape and yep. That's not as pretty as I want, but it should work. Now the problem is our add function becomes it asks tile the module, but we pass in a sphere, which is not as convenient as I want. So I will add another helper function. Or we can just use build shape in place. But I think that's too inconvenient in this case. Build shape takes a type. what is this? Oh, we probably don't need that. Yeah. This works, but I don't like this. Probably we should just make this add function polymorphic as well. So we can even just do this. Nope. We still need to have some kind of constraint into it, which makes sense. This is not template. I think that works, but probably now we need to explicitly put we need to explicitly put a module in, but that's a lot better than what we previously have. Like add sphere, we need to add sphere, add moving sphere, and later we probably need to add even more stuff to it. That looks better. Test pass. Let's do some sanity check of this is way too slow. That's the whole point of next chapter, which is to accelerate the data structure. So after you implement that, our ray tracing will be order of magnitude faster. Currently, we just need to change a little bit. Yeah, while waiting this to finish. For every sphere with Lambertian material, the book changes it into moving sphere. So we need another center. Center 2 is center plus. Oh. Here become moving sphere. If someone know if it is possible for OCaml to somehow infer this module, then please tell me in the comment, because I am curious. We have moving sphere here, moving sphere here. It's duplicating information, even though at least the good thing is the compiler is smart enough to catch that. And the time is from 0 to 1. Yep. You haven't finished yet. This is just way too slow for... Oh, I see. Because I rendered this image in high resolution before, I just forgot to put it back. Let's do this, just make it quick, even though the image quality will be really low. Done. If the quality is too low, we can do 100 afterwards. Let's see. We can kind of see motion blur, but I think it's worthwhile to just do 100 pixel. It's not too slow in that case because we scaled down the resolution. Now, while we are waiting, we can go back into the moving sphere and think about what can we do to I think the majority of the code are the same to the sphere intersection, except this line. So we can probably even just construct a sphere here. Okay, let's see the result first. We can see the motion blur here. So functionally, we already implemented everything this episode I want to implement. There are absolute no hope even I spend the next hour just doing this. So I will not even try. And I expect next episode will be pretty long because of how much stuff we need to do. But first, we don't want this duplicated code nonsense. Sphere hit ray, just ray. I think that's it. We'll see if the test still passes, because test is faster than... Okay. Now let's just wait. That's quicker than I expected. To implement everything I want to implement today. So this may be a short episode if we are just done with everything. So for next episode, we will talk about bounding value hierarchy. It is one of the most used accelerating data structure for ray tracing. The idea is basically we have a lot of objects, and every time we check ray object intersection, we check ray against every object. But if we group objects in some smart way, like here we say some object is in this red box, some object is in this blue box, and if our ray do not intersect with the red box, then it is impossible to intersect with anything inside, and this way we can just exclude the whole red particles and just look at the blue ones. And then this is a hierarchy. That means we will just split our object down and down. This way, we're basically changing ON algorithm. It's like not even ON. Let's say if n is the size of the object, if n is how many objects we have, and we change an ON algorithm into O log n. That's why it can be order of magnitude faster, and with more complex thing, it will be even more significant. Okay, everything still works. Let me push and just stop here. What? Don't know what's going on with Emacs. What is this? Okay, I will trying to commit after the string is ended. Thank you for watching this episode. If you like this kind of ray tracing in a functional language, or if you like my other content, then feel free to subscribe. Thank you.